Today's lesson is 2.5, Continuous Domain and Range. We're going to go ahead and start with graphs with no endpoints. Remember that the domain is the set of all input values, our independent or our x values in a relation or function. The range is the set of all output values, the dependent or the y values in a relation or function. A function or relation has continuous domain and range if its values are unbroken over a part of the graph. And remember, when we write our domain and range, we write it from least to greatest. Let's go ahead and take a look at these first three graphs that have no endpoints. Notice that our domain for our first one, it would continue going, let me grab my right color here. It would continue going in this direction, which is the negative infinity direction. And on the right side, it would continue going in the positive infinity direction. So we can see that our domain is from negative infinity to positive infinity, making our domain all real numbers. When we look at the bottom of our graph, it is going to continue in this downward direction, which is negative infinity as well. And it's going to continue at the top in an upwards direction, which is positive infinity as well. I'm seeing both infinities, so I'm going to go ahead and use all real numbers once again as my range. So just to show you one last time, the domain is all real numbers and the range is all real numbers. Let's go ahead and take a look at these two special cases. Notice that the next graph, as I look at the domain, it does continue to the left to the negative infinity direction. Go ahead and add that on there. And it does continue in the right direction towards positive infinity. So for my domain, I am going to go ahead and say all real numbers. However, when I start looking at my range, what I notice is that my arrows are both pointing in an upward direction. Oh, why is it doing that? Hold on a second, guys. There we go. Both are pointing in an upwards direction. Both are pointing towards positive infinity. Neither one is pointing towards negative infinity. That's because down here at the bottom of my graph, I have what is considered to be a floor. And I have a floor at the y value of negative 1, 2, 3. Since I have one infinity and one number, notice I have positive infinity and the number negative 3, I am not going to use all real numbers. I am also not going to use my form of less than y, less than y, less than. I'm not going to use this form because it's not a compound inequality. I'm going to decide, is it greater than or is it less than? And I'm going to use my infinity to help me make that decision. Let me go ahead and remove this for you right here. There we go. If I am only seeing negative infinity, I am going to use the less than symbol. But for this one, since I see the positive infinity, I'm going to go ahead and use the greater than symbol. I get to make the choice if I should add the bar or not, depending on if it's open or closed. Remember, however, if it is open, you will definitely know that there is an open circle at that point. So we're going to go ahead for this one and add the bar because there's no obvious open circle, and we're going to say that our range is y is greater than or equal to negative 3. And once again, we chose greater than because we saw the positive infinity, so I'm going to use this inequality. Let's take a look at our last one. Once again, our range is showing movement to the left and movement to the right. So once again, I'm seeing negative infinity to the left and positive infinity to the right. I'm going to go ahead and say that my domain is all real numbers. This time though, when I start to look at the bottom of my graph, both of my graphs are moving in a downward direction only, negative infinity. They are not pointing in an upward direction, so there's no positive infinity. This time I have a cap at the beginning, at the top, or what you could call a ceiling. And I have that at a y value of positive 1. I'm going to go over and I'm going to reference right here. I have negative infinity, so I'm going to use less than. And I'm going to go ahead and say less than or equal to because there is no obvious opened circle at the negative 1. Let's go ahead and practice this. Let's look at these two right here, or these three right here. All right, let's go ahead and do our domain first. So let's go ahead and do our domain. Remember, for the domain, you want to go ahead and look at what's happening to the left, negative infinity, and what's happening to the right, positive infinity. I'm going to go ahead and say all real numbers. Now I'm going to go ahead and I'm going to do my range. I'm going to go to my arrows and I'm going to notice that both of them are pointing in an upward direction. They should be pointing upward straight. So that's positive infinity. I do notice that there is a floor on my graph, and my floor is at the y value of 1, 2. If I need to, I can reference my my little cheat sheet right here. So I'm going to go ahead and do that. We have positive infinity, so we're going to do greater than. We are going to say greater than or equal to because there is no obvious open circle. Let's go ahead and take a look at the next one. On the left, we're heading towards negative infinity. On the right, we're heading towards positive infinity. My domain, once again, is all real numbers. Okay. The bottom of my graph would be this one, and it is pointing to negative infinity. The top of my graph would be right here, and it is pointing towards positive infinity. This time for my range, I am seeing both negative and positive infinity, so I'm going to go ahead and say all real numbers. Pause the video to try the last one on your own. Hopefully you noticed that for the domain, it's heading towards negative infinity on the left and positive infinity on the right. So once again, our domain is going to be all real numbers. Hopefully you notice that both of your bottoms of your graph are pointing towards negative infinity for your range, which means there is a ceiling at the top. And that ceiling is at y equals negative 1. Oops. So we're going to say that our range is y is less than or equal to negative 1 because we do see negative infinity. Graphs with one endpoint frequently have domain and range in the form of x is greater than some number or y is less than or equal to some number. Where all my x values and y values are larger than or smaller than their maximum or minimum values. Let's go ahead and take a look at these three examples that they have for us right here. What I want you to notice is that on the left side of your graph, you kind of have this wall, and this wall is at x is equal to negative 2. And then notice on the other side, the graph would continue on the right to positive infinity. So once again, we're seeing that positive infinity, that would trigger us to use greater than, and we're going to say that x is greater than negative 2. The reason we are not using the or equal sign is because, take a look at that hole, it is open, that point is open. It is a very obviously open hole, and so we're going to use just less than. If I read my graph from bottom to top, I notice here at the bottom, once again, I have my floor. Once again, I'm seeing my floor, and my floor is at y equals -5. And then my top is pointing towards positive infinity since it's pointing up, right? So this time, since the bottom is not the open circle, I'm going to go ahead and say y is greater than because of the positive infinity that we see right here at the top, and equal to -5. Okay, so we're just going to keep going in that same direction, right? The left side would point to negative infinity, and this time the wall is on the right side at x equals 3. I would use less than in this case because it is negative infinity, and I'm not going to do less than or equal to because the circle at the point at 3 is open. This time I do have a floor on my ceiling, or sorry, a floor on my graph one more time. And this time the floor is at -4. I'm just counting 1, 2, 3, 4. And since I'm heading from 0 in the downward direction, it is negative. Remember, negative, negative, from 0, positive, positive. These are our directions. If I look at the top of my graph, it is pointing upwards towards positive infinity. I'm going to go ahead and use greater than, and I'm going to say y is greater than -4. I'm not going to use the or equal to bar because the point at 4, my floor, is an open circle. The last and final one, hopefully you're catching on to this pattern. You're going to look here on the left side, and it is obviously a wall here at x is equal to 0. There is not a point there, but if there is not a point there, it is implied to be a closed point. I don't always have to put it to make it be a closed point. On my right side of my graph, I am going to be continuing to positive infinity. I'm going to go ahead and say x is greater than or equal to 0 because once again, that circle at that point at 0 is not obviously open, so then it must be closed. This time, if I look at the bottom of my graph, it is heading in the downward direction to negative infinity, and there is a ceiling at the top of my graph. I'm going to spell ceiling wrong, you guys. No, there we go. Oops, there's a ceiling at the top of my graph, and the ceiling is at the point y equals 4. I'm going to go ahead and use y is less than or equal to 4. And once again, I'm using less than because of the negative infinity at the bottom of my function. And I'm going to use the or equal to bar because this point is obviously closed and not open. Let's go ahead and practice 3 of them on our own. All right, remember, please don't worry about the verbal description. So I'm going to go ahead and cross that part out right now. Let's go ahead and start. On the left side of my graph, the first point I see is right here at this wall. This wall is at x is equal to -2. And once again, here's my 0, and I counted 2 in the negative direction. All right, if I continue to the right side of my graph, it is going to be pointing in this direction, which is positive infinity. I'm going to go ahead and use x. I'm going to go ahead and use greater than because I see positive infinity, and I'm going to do -2. I'm going to go back and look at my point at -2. It is open, so I am not going to put the or equal to bar. Now I'm going to go ahead and look at my range. I'm going to look at the bottom of my graph. Here is the bottom of my graph. I do have a floor, and my floor is at y equals -1, 2, 3. At the top of my graph, I do see an arrow pointing in the upward positive infinity direction. I'm going to go ahead and say that my range is y is greater than, once again, -3. All right, let's take a look at our next one. My ceiling, or sorry, my wall would be right here on the left side of my graph at x is equal to 1. On the right side of my graph, it is continuing to the right, which is positive infinity. I'm going to go ahead and use x and 1 since I see positive infinity greater than, since my circle is closed, or equal to. Let me make that look better. There we go. All right, at the bottom of my graph, it is pointing down to the negative infinity because I see the arrow, and it is creating a a ceiling. I've got to get those two straight in my head. A ceiling at y is equal to 1. Okay, it's not at the point, it's at the part above it where the little, right here. There we go. I'm going to go ahead and say y, and I'm going to use 1, and this time I'm going to use less than because I see negative infinity for the y, and it is a closed point at 1 because it's part of the curved graph, continuous graph, so I'm going to go ahead and say or equal to. All right, our final one, why don't you pause it and give it a try. On the left side of your graph, you should see that it is heading towards negative infinity and that our wall this time is over here on the right side at x is equal to -2. I'm going to go ahead and use x and -2. Since I see a negative infinity, I'm going to use less than. Since my circle at -2 is open, I will not put the bar underneath for or equal to. At the bottom of my graph, I see a floor, and my floor is at y equals 1, 2, 3. As I look at the top of my graph, it is not the circle, but it is the arrow that is heading towards positive infinity. So I'm going to go ahead and use y. I'm going to go ahead and use 3, and I'm going to go ahead and use greater than because I see positive infinity. And I am going to use the or equal to bar because the circle is not one of my bottom or top points. Okay. Graphs with two endpoints frequently have a domain and range in the form of a number less than or equal to x less than or equal to a number. So this is where we're going to start to use our form. This is our form for domain. And for range, it's the same form, a number less than y less than or equal to a number. The part in the middle is the form. You're always going to go ahead and start with less than, the variable to use for domain, x, the variable to use for range, y, and then less than again. You're going to come back and you're going to make your decision on if you should use the bar or not based off of what types of points they are. We can apply the same idea that we did in the last one. Notice here our wall on the left side is at x equals 0. See where I can put it at x equals 0. And our wall on the right side is at x equals 4. So I'm going to go ahead and I'm going to say that my domain is from 0 is less than x is less than 4. We went back and added the or equal to bars because both of our circles are closed. All right, we can say that our floor is here at y equals 0, and our ceiling is here at y equals 2. So we're going to go ahead and we're going to put our range as 0 is less than y is less than 2, and we're using the or equal to bars because both of them are closed points. Our last worked out example, notice right here is our wall to the left at x equals -1, and our wall on the right is at x equals +2. Notice that our wall on the left is an open symbol, so we're going to use just -1 is less than x. Our, our point on the right is a closed one, so we're going to say less than or equal to 2. Our range, the bottom, our floor, is down here at y equals -5, and our ceiling is up here at y equals 4. Our floor is closed, so we're going to say -5 is less than or equal to y. Our ceiling is open, so we're going to say less than 4. Let's go ahead and practice. All right, so let's always start with domain. Remember, you're putting your walls. Put up your left side wall. This wall is at x equals -2. And put up your right side wall, x equals 6. Remember, always left, then right. All right, so we're going to say -2. We're going to use the form less than x less than, and then we're going to put our right side 1/6. It always goes left, less than x less than the right side number. Now we're going to come back in and we're going to go ahead and look. This one is dictated by the type of circle you see here at this number. It is open, so we're going to leave it as less than. This one is determined by the 6. This symbol is closed. This circle is closed. So we are going to go ahead and add a or equal to bar. All right, let's go ahead and put on our floor. Here is our floor at y equals -2. And put on your ceiling. Here's your ceiling at y equals +2. We're going to go ahead and we're going to say -2 less than, we're going to change the variable to y because we're doing range, less than, and 2. Notice our floor is going to do this one, so -2 is closed. So we're going to, oops, no, bring that back. There we go. Is going to be less than, and our ceiling is open, so we're going to leave it as just greater than, or I'm sorry, just less than. All right, go ahead and put on your wall at x equals 1. Your left wall, go ahead and put on your right wall, x equals 1, 2, 3, 4. We're going to go ahead and say 1 less than x less than 4. Both of our circles are open, so we're not going to put a bar on either one of them. Let's go ahead and put on our floor. This time our floor is not the point, but our floor is this bottom part of the graph, and it is at y equals -1. And this point, it would be considered our ceiling at y equals 2. So we're going to go ahead and use the numbers -1, our form in the middle with the variable y, and +2. This time, and I know this sounds a little crazy because we have the two open circles, but our floor is on a closed point, so I do want to make sure that I put the bar. It is not the open circle, the floor, so we do have to add the bar because it is a curved, continuous part of the graph. Pause the video and see if you can get the last domain and range on your own. All right, hopefully you added your wall here on the left at x equals -4. And you added your wall here on the right at x equals +4. You're going to go ahead and put -4 is less than x is less than +4. The circle at -4 is closed, so we need to add the bar, but the one at +4 is open. All right, for our range, our floor is right here at y equals -5. And our ceiling is right here at the top at y equals +1. We're going to go ahead and say -5 is less than y is less than 1. The circle at -5 is closed, so we need to go ahead and add the bar. If you'd like to try to sketch a graph of a function whose domain is -3 less than x less than +2, and a range of +4 is less than or equal to y is less than 6. All right, our final one, and I know you probably thinking, we got it, we got it. But these are some special cases, vertical and horizontal lines. Horizontal lines have a domain of all real numbers and a range that is y equals a given number. Our vertical lines have a range of all real numbers and a domain of x equals a number. Take a look here at our two lines. We have first our horizontal line. Our horizontal line, notice it mimics our floor or our ceiling line. This is why it has a range of -2. -2, notice, is the point where it is touching the y-axis. Because it is continuing in the left direction towards -infinity and in the right direction towards +infinity, we would call its domain all real numbers. Take a look at our vertical line. Our vertical line is not going to the left or to the right. It is only touching the x-axis at a given number. That number is our domain. So it's only touching right here, and so this is our domain. However, if you look at its range, at the bottom, it is heading towards -infinity, and at the top, it is heading towards +infinity. This was why our range would be all real numbers. Let's go ahead and take a look at these three. Okay, so for the first one, we have a vertical line. And if I look up above, I know that my range is going to be all real numbers and that my domain is going to be x equals, and I need the number where the graph is touching the x-axis. That looks like -1 to me. In the next one, if it's hard to see, the graph is right here on the x-axis. So I know that my domain is all real numbers, and my range is going to be y equals the number where the graph is touching the y-axis, which would be 0. Go ahead and pause the video and see if you can get the last one on your own. It is a vertical line once again, so if I look from up above, my range is going to be all real numbers, and my domain is going to be the x value where the graph is touching the x-axis. That does appear to be 4. There is a try it at the bottom to sketch a graph of a function with domain of all real numbers and a range of 5.